All right, so this is the PowerPoint for week 6 that I'm recording live, and I'm sort of building it as I go. But the main topic for this week is the chain rule. Okay, and the chain rule works for composite functions. And so it says, let f and g be functions for all x in the domain of g, for which g is differentiable at x, and f is differentiable at g of x. Okay, the derivative of the composite function, so that's the composite function, which is this, right? So it's h of x, and it's made up of g inside of f. So you take, to get the derivative, you take the derivative of the outside function and leave the inside function as is. And then you take the derivative of the inside function. So this notation is sometimes helpful. Dy dx is dy, so that the y is the outside function and u is the inside function. But it's, well, maybe both of these are hard to understand. All right, so there is a power rule for composite functions, and I think it's important to show it, but I don't know how important it is to necessarily memorize it, because it's just an application of the chain rule. Okay, so all right, that said, there's an example there, and I am gonna take the example and we're gonna go ahead and try it. And see if my explanation makes sense, and then of course give you a chance to ask questions if you have any. I think the questions that I do get from my live studio audience of 1 will not be recorded, so you'll just get the main parts of it. So let me just make sure I am sharing that paint screen. Okay, so this is what we have, and it is, for this example, it is a good idea to take h and rewrite it. And I'm using the power rule, but I'm mainly using the chain rule, which is the power rule that I showed you, that I briefly displayed, is an application of the chain rule. So what I'm going to do is I'm going to rewrite this function. And can you please confirm that you're seeing my paint screen?
Yes, I can see it.
Okay, perfect. So I'm going to rewrite this as 3x squared plus 1. And in order for this to be in the numerator, I'm going to put -2. Okay. So the idea is to treat, let me use a different color so that it'll come out just a little lighter. Let's use a light blue. The idea is to treat this inside function as a variable. Now, the variable that we'll use when we use the other notation is u. And so the basic rule for the basic power rule, the basic one, it has you take this -2 and bring it down here and then subtract 1. Okay, so that's basically going to be might be the hardest part to see. Then you have to take let's do it in green. Then you're going to have to take that piece and find its derivative over here. And of course, the derivative of, so maybe just real quickly, let's just see. Let's say if u is 3x squared plus 1, then u prime is 6x, take away 1. Well, it's just 6x. Okay, so I'm gonna erase some of this just because I think it'll be confusing. So I'm gonna actually just, I want to write that to give you a sense of, oops. Okay, we're almost there. So now we're taking the derivative h prime. So this 2 comes to the front. And you subtract 1 from the -2, so that's -3. And then you need the derivative of this function, which we already talked about. And that is 6x. Okay, so that's really it. I think, let me use a different color. Just to point those two things out, which is -12x, because I'm using this x over here. And then since I have a negative exponent, I might as well just put it back on the bottom. And that's to the 3rd power. So that's the way you would solve that problem with the chain rule. All right, so let's go ahead and look at another problem. And we're gonna again use the chain rule. And I think part of the trouble with this one is that it's a little hard to read if you don't understand why the 3 is in the middle. But it's h of x is sine of x cubed, basically. So let's go ahead and take a look at that one. H of x is sine cubed x. So let's go ahead and take a look here. So it's h of x is sine cubed x, which visually is hard to decipher, because I think if I had written it this way, that would have made more sense. Then it's the power rule, right? So you're taking h prime of x, and so again, if we treat this part as the u, and this is like u cubed, then you know the 3 has to come to the front, and then you subtract 1. But then we have to take the derivative of sine x. So what that amounts to is we end up with 3. That's a multiplication times the sine of x. Take away 1 from the 3, that's a 2. And then I have to take the derivative of the sine of x. So du dx, in other words, the derivative of the sine of x with respect to x, that's cosine of x. So that's what goes next. So times the sine of x. And there's, oh, my bad, that times the cosine of x. Those parentheses aren't necessary. And you might, H prime. You might need to follow the conventional notation, which puts the 2 in the middle. So that's how you would do that problem. All right, so this is more of the chain rule, but I like the top one because it requires you to find the equation of a tangent line. So that's an extra step. And then the other one just kind of looks at where we have to think about the derivative of cosine. So let me go ahead and take, let me take a copy of those real quick here so that I can share it on a paint screen. All right. So let me take the first one. And let me go ahead and open up paint screen. Things you can't see, they're kind of happening behind the scenes here. All right, let me go ahead and share what I can. All right, so this is a problem, okay? So we want to find the equation of the tangent line to that graph. And it might be worth looking at that graph. And then maybe even graphing the line. I think doing those two things will be really helpful. So let's find the derivative of the function, because that'll give us the slope of the line. And then we'll evaluate it at that point. So finding the derivative will give us the equation for the slope, and then we will specify to that point. So this 3 is going to come to the front. And then we have x squared minus 2. You leave that alone. You subtract the 1 from this 3. So that leaves me a 2. And then you have to take a derivative of, so if u is x squared minus 2, then du dx is 2x, it's just 2x. So that's what this is. All right, but we want to evaluate it at x equal -2. So 3 times -2 squared minus 2 squared. I'm just plugging it in. You've done that a bunch of times in other contexts. So this is 3. This is 4 minus 2. 2 squared is 4. If you're here live, you might want to check my work. And this is -4. Okay. So 16 times 3 is, so I'm getting -48 is what I'm getting. Okay, so it's always worth double checking your work. So the 3 was brought down, that was made a 2. You left the inside alone, then you take the derivative of the inside, which is 2x. Then we plug in a -2 because that's where we're evaluating the slope. So this is going to be the slope. -2 squared is 4. 4 minus 2 is 2. 2 squared is 4. Okay, yeah. So this is this 4. This 3 is this 3. And then 2 times -2 is -4. 3 times 4 is 12. Times 4 is 48. All right, that looks good to me so far. It might be worth, where can we do it? Let's do it down here. We need not the derivative. We need the equation evaluated at that same point. So the original equation, which is up here. So it's -2 squared minus 2. And that's it, right? That's the whole thing. So -2 squared is 4. Wait, I'm missing something. I'm missing the cube. That is not it. That is not everything. I needed that piece. Okay, -2 squared is 4 minus 2 is 2. 2 to the third power is 8. Okay, so this is 8. I'll just make a big kind of fat 8 there. All right. Why do I want that? Because I need this point. Because my go-to when they ask me for an equation of a line, my go-to is the point slope form.